Welcome to the 3Dflow Academy. In this video, we'll learn how to add ground control points in 3ds Zephyr using two different approaches, and then use them to scale and georeference a 3D model. Here, we will use a drone dataset made of 244 images acquired over a large stockpile. Several surveyed targets were placed across the scene, and their coordinates were measured on site using GNSS instrumentation. It is important to note that adding GCPs and then scaling and georeferencing the project before generating dense point clouds or meshes is strongly recommended. This is because bundle adjustment, enabled by default, removes any 3D element from the project except the sparse point cloud. That's why only the sparse point cloud is visible in this project. To add a new control point from images, check the Control Points panel and click the From Images button to open the GCP editor. Scroll through the image list on the left until you find a picture showing the ground target you want to mark. Inside the GCP editor, you can also rename the control point before clicking OK to add the GCP to the project. Once the GCP is marked in the first image, Zephyr provides an initial hint by sorting the image list and suggesting additional images where the same point can be marked. To speed up the process, you can also use the left and right arrow keys on the keyboard to scroll through the images and open them to mark the point. Alternatively, you can use the automatic matching button to let Zephyr mark the point for you. Click OK to add the GCP to the project, then repeat the same operation for each target placed in the scene. Please note that the local and global reprojection errors appear in the bottom right-hand corner of the GCP editor as soon as the same point is marked on a second image, while a red circle estimating the correct position of the point appears once the point has been marked in a third image. Aside from the hints provided by Zephyr, make sure to mark the point in the same position across the images and use as many images as possible per point, since camera optimization will benefit from that when scaling and georeferencing the project. Once you have added all the GCPs to the project, you can now proceed with scaling and georeferencing. Click the Align Model with 3D Constraints button in the Control Points panel, and then click the Import Constraints from File button in the dialog that opens. Select the text or CSV file, which includes the real-world coordinates, and click Open. In the Import Constraints window, click the Reference System drop-down menu to select one suitable for the coordinates you are importing. From the same drop-down menu, you can also access the Reference System database. Search for a specific system by name or EPSG code, and even set a geoid model if needed. Click OK in the Reference System database window, and then click OK again in the Import Constraints window to assign the coordinates to the GCPs. You can leave bundle adjustment enabled, and if needed, you can choose a different target coordinate system from the corresponding drop-down menu. Click OK to start processing. Once scaling and georeferencing are complete, Zephyr shows an error report including the final mean residual, the RMS error, and the residuals for each individual GCP and coordinate. You can always check the error report by clicking the Constraints Report button in the Control Points panel. You can also click the Tools menu, select Control Points, and then show alignment info if you want to reopen the same report shown at the end of the scaling process. Now let's move on to the second method. Click the Import 3D button in the Control Points panel. Click the Browse button in the dialog that opens and select the text or CSV file containing the GCP coordinates. Select the corresponding reference system from the drop-down menu. Click OK and check the table of GCPs and their coordinates. Click OK to import the GCPs into the project. Please note, to add GCPs correctly, the Zephyr project and the coordinates you want to import must use the same reference system. Now it's time to link the GCPs to the project images. To do this, right-click the GCP name in the control points list and select Edit. Mark the control point in the images the same way we did earlier when adding GCPs directly from the images. As you can see in the control points editor, Zephyr has already sorted the images, suggesting the ones that are closest to the GCP position in the 3D workspace. Click OK once you have marked the same GCP in at least 3 images. Again, the more images involved in this process, the more accurate the camera optimization will be. The same operation must be repeated for every GCP imported into the project. We've now marked all the GCPs across the images using as many images as possible for each point. To run camera optimization, simply click Align Model with 3D Constraints in the Control Points panel and then enable the Perform Bundle Adjustment option in the new window. Please note that you do not need to re-import GCP coordinates when selecting a different target coordinate system. Click OK to start processing. As we have already seen, once the process is complete, Zephyr displays an error report including the final mean residual, the RMS error, and the residuals for each individual GCP and coordinate. You can always check the error report by clicking the Constraints Report button in the Control Points panel. You can also click the Tools menu, select Control Points, and then show Alignment Info if you want to reopen the same report shown at the end of the scaling process. Now that the project has been accurately scaled and georeferenced, you can move on to the 3D model generation, which will produce the dense point cloud and the mesh. And that completes this tutorial on how to add GCPs to a Zephyr project. If you have any doubts or questions, feel free to contact 3Dflow technical support at support@3dflow.net.